So we are going to discuss calculus from NCERT of math, right? So calculus में अपने जो portions लगाते हैं उसमें अपन continuity and differentiability पढ़ते हैं और applications of derivatives पढ़ते हैं और उसके अलावा from the part 2 there comes another set of chapters. पहले अपन continuity and differentiability से चालू करेंगे एंड क्योंकि इसकी जो NCERT है स्पेशली फॉर इंटीग्रेशन आई वुड से ये जो NCERT में जो स्टफ दिया हुआ है जो उनके अंदर दिए हुए हैं कि किस तरह से हम किस तरह के इंटीग्रल्स करेंगे वो बहुत ज़्यादा अच्छे से दिया हुआ है तो इसलिए अपन उसको कवर करने की कोशिश करेंगे द होल साइंस इज नथिंग मोर देन अ रिफाइनमेंट ऑफ एवरीडे थिंकिंग एल्बर्ट आइंस्टाइन ने बोला था ये बात ठीक है तो उनके लिए ऐसा था एंड वी आर नॉट लाइक दैट टाइप ऑफ पीपल एनीवेज अच्छा आइजैक न्यूटन का भी यहाँ पे बहुत अच्छा रोल आ जाता है सर आइजैक न्यूटन का ठीक है इनकी शक्ल में जब भी देखती हूँ मुझे अलग अलग फोटोज अलग अलग टाइप में जो अलग अलग फोटोज में देखती हूँ वो मुझे अलग अलग ही लगती है एनीवेज 1642 से 1727 not at all important for the board point of view or any other exam point of view in terms of number of years a person lived or the years through which a person lived anyways in the introduction, they are saying this chapter is essentially for a continuation of our study of differentiation of functions in class 11th. We had learned to differentiate certain functions like polynomial functions and trigonometric functions. In this chapter, we introduced the very basic concepts of the very important concepts of continuity, differentiability, and the relations between them. We'll also learn differentiation of inverse trigonometric functions. Further, we introduced a new class of functions called exponential and logarithmic functions. These functions led to powerful techniques of differentiation. We illustrate certain geometrically obvious conditions through differential calculus. In this process, we learn some fundamental theorems in this area. So calculus makes the questions more easier in that point of view. So they are very important. And अपन ऐसा है कि अपन जैसे जब मैं आई जब मैं इस चीज़ की तैयारी कर रही थी आई क्यूजेस की तैयारी कर रही थी उस टाइम पे कैलकुलस वाज नॉट अलाउड बिकॉज हम छोटे बच्चे थे लेकिन इसके बाद हमें रियलाइज हुआ कि हमें बेसिक कैलकुलस तभी पढ़ाती जाती थी ठीक है लेकिन अब हमने आके 11th 12th में ही आके इस जो प्रॉपर कैलकुलस है जो मैथ्स वाली कैलकुलस है उससे हम तभी इंट्रोड्यूस हुए हमें सब मना करते थे बिफोर दैट कि तुम्हें ये वाला चीज़ करनी चाहिए बट ऐसा हमें आने के बाद पता चला उतना ज़्यादा तो डिफिकल्ट था नहीं और दो क्वेश्चन तो डिफिकल्ट पूछ ही रहे थे continuity की बात करते हैं we start the session with two informal examples to get a feel of continuity consider the function f(x) equal to 1 if x is less than equal to 0 and 2 if x is greater than 0 this function is of course defined at every point on the real line graph of this function is given in the figure so we can see this graph इसमें जो undark circle है जो dark circle है उसको आप देख सकते हो one can deduce from the graph that the value of function at nearby points on x-axis remains close to each other at x equal to 0 at the points near and to the left of o or 0 it at the points like minus 0.1 minus 0.0 and minus 0.001 the value of the function is 1 at the points near to the right, which is right of o, which is like points 0.1, 0.1, 0.001, the value of the function is 2 using the language of left and right hand limits. We may say that the left, respectively right, hand limit of f at 0 is 1, respectively 2. In particular, the left and right hand limit do not coincide. We also observe that the value of the function at x equal to 0 coincides with the left hand limit. Note that when we try to draw the graph, we cannot draw it in one stroke. Without lifting the pen from the plane of the paper, we cannot draw the graph of this function. In fact, we need to lift the pen when we come at 0 to from the left. This is one instance of function being not continuous at x equal to 0. If the function is continuous from any point to any point, we can just make a random this thing and that would happen. I'll just close this cupboard of mine. Okay. ठीक now the next thing is तो अब उनको पेन उठाने की जरूरत पड़ जा रही है समझ रहे हो we need to lift the pen when we now consider the function defined as f(x) equal to 1 if x is not equal to 0 and 2 if x is equal to 0 this function is also defined at every point ठीक है इसका left and right hand limits are both equal to 1 but the value of the function at x equal to 0 equals to 2 which does not coincide with the common value of the left and right hand limits again we know that we cannot draw the graph of the function without lifting the pen this is yet another instance of function being not continuous it seems to be continuous except only at one point still it is not continuous this is we can say like that namely we may say that the function is continuous to fixed point if I can draw the graph of the function down that point without lifting the pen from the plane of the paper mathematically it may be phrased precisely as follows definition one is that suppose if a function or real function on a subset of the real numbers and c can be any point in the domain of f then f is continuous at c if the x tends to c, fx equal to fc. More elaborately, if the left hand limit, right hand limit, and the value of the function at x equal to c exists and equal to each other, then the function f is said to be continuous at x equal to c. Recall. Recall that if the right hand limit and the left hand limit at x equal to c coincides, then we can say that the function or the common value is the limit of the function at x equal to c. Hence, we may also rephrase the definition of continuity as follows: the function is continuous at x equal to c if the function is defined at x equal to c, and if the value of the function at x equal to c equals the limit of the function at x equal to c. If f is not continuous at c, we say that f is discontinuous at c, and c is called a point of discontinuity of f. Check the continuity of the function f is given by fx equal to 2x plus 3 at x equal to 1. Note that the function is defined at the given point x equal to 1 and its value is 5. Then find the limit of the function at x equal to 1. Clearly, fx tends to 1 by it's 5, and x tends to 1 by fx equal to 5 equal to f of 1 also, right? Uh, Hence, f is continuous at x equal to 1, right? Examine whether the function f given by fx equal to x square is continuous at x equal to 0. First, note that the function is defined at a given point x equal to 0 and its value is 0. Then find the limit of the function at x equal to 0. Clearly, x tends to 0 by fx equal to limit of x tends to 0 of x square is equal to 0 square equal to 0. X tends to 0 by fx equal to 0 is equal to f of 0. Hence, f is continuous at x equal to 0. This is how you have to write the answers, right? Then comes discuss the continuity of the function f given by mod x is at x equal to 0. By definition, we can say fx equal to minus x if x is less than 0, x is equal to fx equal to x if x is greater than equal to 0. Clearly, the function is defined at 0 and f is 0 equal to 0. Left hand limit of f at 0 is limit of x tends to 0 minus fx is equal to limit of minus x tends to 0 minus is equal to 0. Similarly, the right hand limit of f at 0 is 0 plus by limit of x tends to 0 plus is equal to 0. Thus, left hand limit, right hand limit, and the value function coincide at x equal to 0. Hence, f is continuous at x equal to 0. Should the function be given by q plus 3 when x is not equal to 0, even if x is equal to 0 is not continuous at x equal to 0. The function is defined at x equal to 0 and its value is x at x equal to 0 is 1. When x is not equal to 0, the function is given by a polynomial. Hence, fx is the x into 0 is 3. Since the limit of fs at x equal to 0 does not coincide with f0, the function is not continuous at x equal to 0. It may be noted. So यहाँ पे x0 पे इसकी जो वैल्यू थी वो अलग दी हुई है, बाकी जो फंक्शन की वैल्यू है वो यहाँ पे 3 दी हुई है. Maybe not that x equal to 0 is only the point of discontinuity for this function. Check that points where the constant function f x equal to k is continuous. So f x equal to k is continuous at every point. So it's every real number. The function is defined therefore at all real numbers, and by definition its value at any real number equals k. Let c be any real number, then fx limit x tends to c is equal to limit k x tends to c is equal to k always. Since fc is equal to k equal to limit of x tends to c f x is for any real number c, the function f is continuous at every real number. Prove that the identity function of real numbers given by f x equal to x is continuous at every real number. We can make the graphs, we can very easily visualize it. हमारे दिमाग में जैसे हम क्वेश्चन पढ़ते हैं, अब हम क्योंकि बहुत सारा कुछ पढ़ चुके हैं, हम पूरा 12th का सिलेबस कंप्लीट कर चुके हैं अपना क्लासेस के अंदर, तो अपन के मन में वो ग्राफ बन जाता है. अपन को पता चल जाता है तभी कि वो चीज़ अपने कंटिन्यूस है. बस अपन को लिखना आना चाहिए बोर्ड के पॉइंट ऑफ व्यू से, इज व्हाट आर कंसर्न्स, राइट? वो भी ऐसा मीनिंग आगे के लिख लेंगे. ठीक है, अभी थोड़ा टाइम पास लग रहा है तो अपन अब थोड़ा स्किप करने की कोशिश करेंगे वो पार्ट्स को जो अपन को बहुत ही अच्छे से आ गए हैं. अभी डेफिनेशन 2 उन्होंने बोली है, हैविंग डिफाइंड कंटिन्यूटी एट ऑफ अ फंक्शन एट. अच्छा, अभी खुद ही रुक गए. ठीक है, प्रूव द आइडेंटिटी फंक्शन उन्होंने खुद ही बोल दिया. अब आगे बढ़ते हैं. Having defined continuity of function at a given point, now we make a natural extension of this definition to discuss continuity of a function. तो continuity पहले उठाने की जरूरत नहीं पड़ेगी. ये यहाँ पे उन्होंने पहली डेफिनेशन बोली थी, बट वो डेफिनेशन नहीं थी. डेफिनेशन प्रिसाइजली ये थी कि उसकी राइट हैंड लिमिट, लेफ्ट हैंड लिमिट और उसके जो उसका जो वैल्यू एग्जैक्ट उस पॉइंट पे है वो बराबर होनी चाहिए. This definition requires a bit of elaboration. The real function f is said to be continuous when it is continuous every point in the domain of it. कोई भी डोमेन में जो एलिमेंट्स होंगे उन सबके ऊपर जो f कंटीन्यूअस होगा, तो फिर सपोज f is a function defined on the closed interval a से b, then for f to be continuous at every point in a to b including the endpoints a and b, because we have had a square bracket. Right, so continuity of f at a means like inverse fx is equal to f x tends to a plus, and continuity of f at b means if b minus by b fx equal to fb. Observe that at lim x a minus fx and f x b plus does not make any sense. As a consequence of this definition, if f is defined only at one point, it is continuous there. This is basically right. If the domain of f is a singleton, f is continuous function. तो अगर अब ये इम्पोर्टेंट पॉइंट यहाँ पे आ गया कि अगर एक ही पॉइंट पे डिफाइंड है तो वो ऑब्वियसली कॉन्टिन्यूस फंक्शन होगा, क्योंकि वो डिफाइंड इस पॉइंट पे है. तो उसके बाद आप एक पॉइंट पे एक डॉट बना दिया मैंने, वो जो डॉट है, एवरी डॉट ऑफ द नंबर लाइन इज अ कॉन्टिन्यूअस फंक्शन इन इटसेल्फ, राइट? बिकॉज आपने उसको डिफाइन ही इस तरह से किया है, इज द फंक्शन डिफाइंड बाय एफ एक्स मॉड एक्स इज अ कॉन्टिन्यूअस फंक्शन। तो मॉड एक्स का ग्राफ अपन को दिख रहा है, कॉन्टिन्यूअस फंक्शन है, अब बस हम उसको प्रूफ करते बैठेंगे कि कॉन्टिन्यूअस फंक्शन कैसे है। if we may write as minus x and x, example 3, we know that f is continuous not equal to 0, let's see any real number such that c is less than 0, f is equals to minus c, limit of fx is f tends to c, and limit of minus x extends to d is minus c. Why? Because minus x minus c, limit of fx equal to f c, x tends to c with f is continuous to all negative real numbers. Now let conceive a real number such that c is greater than 0, उस कंडीशन में प्रूफ कर दिया। तो इसमें जैसे सारे पॉजिटिव नंबर्स पे भी सारे नेगेटिव नंबर्स पे कॉन्टिन्यूस है, और जीरो पे कॉन्टिन्यूस था, तो हर एक पॉइंट पे ही कॉन्टिन्यूस हो जाएगा। डिस्कस द कॉन्टिन्यूटी ऑफ द फंक्शन एफ गिवन बाय